Welcome, everyone. We're going straight to a crucial topic that impacts everyone who interacts with software, regardless if you're a developer or simply a user. It's application security. As our reliance on technology grows, understanding the security implications is paramount, and this is something you've highlighted as a key concern.
Yeah, absolutely. You hit the nail on the head. At its core, all complex software has errors. It's just a fact of life. The problem is that some of those errors can turn into, security vulnerabilities. This means almost every piece of software out there has potential weaknesses.
Right. It's not about pointing fingers at developers. It's more about acknowledging the inherent difficulties in building complex systems. And I think understanding this is really the first step, right? So, today we're going to really try to unpack how these vulnerabilities creep into our software, why addressing them early is critical, and what are some of the more modern approaches that are helping us build secure applications right from the start. We'll also be looking at how security integrates into that entire software development process.
Yeah, I think, one of the most crucial things to understand about this whole process is the difference in cost, depending on when a vulnerability is found. You brought up a really interesting point about this during our prep.
I did. It was this idea that, if you find a bug while you're actually writing the code, it's relatively cheap to fix,
Right.
right? Let's just, for argument's sake, call that cost 1x. But then if that same bug is discovered much later, after the software has been released and people are using it, the cost can balloon, significantly, sometimes as high as like 640 times the original amount. That's just astounding. It really highlights why early detection is so critical. I mean, have you seen examples of where this is played out in a really big way?
Absolutely. I mean, you think about these major data breaches that we hear about all the time. A lot of times, the root cause, right, the vulnerability that was exploited was maybe a seemingly small coding error, but because it wasn't caught early on, the consequences just they just spiral out of control. You have the cost of fixing the issue, potential fines, the damage to your reputation. It just becomes astronomical. What's interesting though is how the way we build software has really evolved, and security hasn't always kept pace.
Right, right. Okay, so let's back up for a second. Traditionally, software development was pretty linear, right? It was design, code, tests, release. Often the people writing the code, the dev team, and the people responsible for running the software, the ops team, were pretty siloed.
Absolutely. It was very much like this kind of assembly line approach,
Yeah.
with distinct stages, not a lot of collaboration. It could be pretty slow and inflexible.
Mhm.
And the key thing is security in this old model. It was often an afterthought. It was something, you tacked on at the end, kind of over the wall,
Mm.
which was really problematic.
Yeah, it sounds like that just made it way too easy for security issues to, kind of slip through until it was too late. So then we had the rise of DevOps, thankfully.
Exactly. DevOps came along and really tried to break down those barriers between, development and operations. It's much more of a continuous loop with lots of feedback and integration between, writing code, releasing it, deploying it, and how it's actually running. It really embraces collaboration and faster cycles of improvement.
Mm.
It's interesting to think about is while DevOps, improved speed and agility, why didn't security automatically become a core part of that? What were some of those like initial blind spots?
Yeah, that's a great question. I think while DevOps did focus on speed and collaboration between the dev and ops teams, security wasn't always, front and center, right? It was
Wow.
still seen as a separate concern. That's really where DevSecOps comes in.
Yeah, absolutely. So you can think of DevSecOps as this idea of embedding security into every single stage of software development, starting with the first line of code. It takes all core principles of DevOps, the collaboration and that speed, but makes security a fundamental part of every stage, not an add-on. And this is really where the concept of shifting left comes in, right? Bringing security considerations to much earlier stages in the development lifecycle.
Absolutely. Instead of waiting until you're testing the software or, even worse after it's released to start thinking about security, you're considering it right from the get-go during design and coding. It's about building security in, not, trying to bolt it on as an afterthought. So I think understanding these modern approaches like DevSecOps is key. But let's get down to the practical level. What are some specific things development teams can actually do to write more secure code?
So there are a few fundamental practices that can make a huge difference. Um, One of the most important is adopting secure coding practices. Basically, these are guidelines for writing code in a way that minimizes vulnerabilities. For example, a really crucial one is validating all input, to prevent things like buffer overflows.
Right, buffer overflows. That's when you feed in more data than the program is expecting, and it can, kind of overflow into other areas of memory, potentially allowing an attacker to take control.
Exactly. So you can think of proper input validation as like having a bouncer at the door of your software, right? Checking that the data coming in is what you expect and that it behaves properly. This prevents attackers from, injecting malicious code or causing crashes. Other important secure coding practices include using strong methods for authentication, like verifying who users are, using encryption properly to protect sensitive data, and making sure the software handles errors gracefully without revealing, sensitive details.
So it sounds like there's quite a bit to keep track of. Are there, any good resources out there for developers who want to learn about these secure coding practices?
Absolutely, yeah.
Yeah.
OWASP, the Open Web Application Security Project, is a fantastic resource. They have a ton of information on their website, owasp.org, including really comprehensive guides on secure coding practices, which are pretty much industry standard.
That's great. So what about the code that developers use that, other people have written? No one builds everything from scratch anymore, right? Everyone relies on libraries and components that others have created.
Yeah, that's a really crucial point. Using these trusted libraries, whether they're open source or commercially available, can save a ton of development time. However, it's important to remember not all code is created equal. Even really well-regarded libraries can have vulnerabilities. The log4j situation is a great example of this.
Oh, right. Log4j, it was a software library used for logging events and applications. And it turned out there was a serious security flaw in it, after it had been used in a ton of places. I imagine that was a nightmare for companies trying to, track down every instance of it and patch it.
It was a huge undertaking and cost companies a lot of time and money to fix. And it highlights how even when you're using established libraries, you can't just assume you're secure. It's essential to stay informed about potential vulnerabilities and update the libraries you're using promptly.
Right. So we've talked about writing secure code ourselves, being careful about the external code we bring in. What else is important in building secure applications?
So defining standard system architectures up front can be really beneficial. By having these consistent blueprints for how systems are designed and how security is approached, you create a much more, solid foundation for security across the organization. IBM's Application Security Architecture Reference is a good resource for guidance on this.
So having those security principles baked into the design from the start really makes a difference. You mentioned earlier mistakes to avoid, and you brought up the OWASP Top 10 list. Can you tell us more about that?
Absolutely. The OWASP Top 10 is this really interesting list that identifies the most common security vulnerabilities found in web applications.
Yeah.
And what's striking? When you look at this list over time, say from 2017 to 2021, while the order might change, a lot of the types of vulnerabilities remain the same. Things like injection flaws, where attackers try to insert malicious code into your application, and those input validation errors we talked about earlier, they keep cropping up. So it's a good reminder that these fundamental security challenges are still very much present.
Yeah, it is a bit concerning that we're still seeing those same vulnerabilities popping up years later. It really underscores the need for, ongoing education and awareness about these core weaknesses. You also mentioned something called a software bill of materials, or SBOM. Is that right?
Right. An SBOM is essentially like an ingredient list for your software. It breaks down all the different components that make up your application, where they came from, what other components they depend on, and what specific versions you're using. Think of it as knowing exactly what's inside your software.
And how does that play into security?
Well, if a vulnerability is discovered in one of the components you're using, like think back to the log4j example, having an SBOM allows you to quickly identify all the systems that are using that vulnerable component. This means you can respond much faster, patching those systems before attackers can exploit the vulnerability.
Oh, okay, that makes sense. It's like having a map of all the potentially risky parts of your software. So we've talked about building security through secure coding, being careful about external code, having those standard designs, learning from common mistakes, and tracking our components with these SBOMs. What about actually finding those vulnerabilities in the code?
Right. This is where automated vulnerability testing comes in, which is, a core element of DevSecOps. There are two main types of automated testing: static application security testing, or SAT, and dynamic application security testing, or DAST.
Okay, SAST and DAST. What's the difference between the two?
So SAST is kind of like looking at your application's code without actually running it. It analyzes the source code, to identify potential vulnerabilities. Think of it like a grammar and style checker. But for security, that runs before you even start the program. This helps you catch those vulnerabilities early on in the development process when they're the cheapest and easiest to fix.
So SAST is kind of like a security review of your blueprints before you even start building. What about DAST?
DAST, on the other hand, tests your application while it's running. It tries to find vulnerabilities by basically simulating attacks from the outside. It doesn't look at your source code directly. It interacts with the application the way an attacker would.
So DAST is like testing the finished building by trying to break in, seeing if you can find any weak points in its defenses.
Exactly. And the key thing is that SAST and DAST are not, mutually exclusive. They complement each other. SAST can find certain types of vulnerabilities by looking at the code's structure, while DAST can uncover issues that are only apparent when the application is actually running. The best strategy is to use both throughout the development process as part of that continuous DevSecOps loop.
So you need both the internal code analysis and the external, like, attack simulation for a complete picture of your application security.
Now, we're seeing a lot of buzz about AI-powered tools, like those chatbots that can, help with coding. Are these a help or a hindrance when it comes to security? That's a really interesting question and an important one. These large language model chatbots, they're kind of a double-edged sword when it comes to application security. On one hand, they can be really helpful. They can generate code quickly for those more routine tasks, like you can ask it to write a specific function in Python, and it can spit out something functional almost instantly. They can also help with debugging existing code, by identifying potential issues.
Okay, so that sounds like it could really speed up development. But what are the potential downsides from a security standpoint?
The biggest risk with these AI chatbots is that they can actually introduce vulnerabilities into the code they generate, because developers might rely on them to write a significant amount of code. Carefully checking all of that code for security flaws becomes a real challenge. And then there's the concern, maybe a bit further down the line, but still a concern, that the chatbot itself could be compromised, potentially leading to backdoors being inserted into the code.
That's a worrying thought. The tool that's supposed to be helping you write secure code could actually be injecting security weaknesses.
Exactly. And you have to remember, these chatbots are trained on massive amounts of data, right? So they're not necessarily a trustworthy source in the same way that, say, a well-vetted open source library might be, where the code has been reviewed by lots of people over time.
Mhm.
When you get code from a chatbot, you're essentially taking it on faith without that same level of scrutiny.
It's like trusting a black box, right? You don't necessarily know the security principles it was built on. You also mentioned a risk associated with using chatbots for debugging. Can you expand on that?
Yes. See, when developers use these chatbots to help them find bugs in their code, they often have to feed, potentially sensitive proprietary code into the system. And this raises concerns about, intellectual property being exposed. The chatbot could learn from that code and maybe even reuse it in other contexts, or inadvertently leak sensitive information. I actually read about a company that decided to restrict the use of these chatbots because their developers were, unknowingly sharing confidential code, which they viewed as a major security risk.
Wow, that's a real world example that really underscores the potential dangers. So while these chatbots can, offer speed and convenience, it sounds like we need to approach them with a lot of caution, especially when it comes to the security of the code they generate and the risks of intellectual property leaks.
Absolutely. They're powerful tools, but they definitely require careful oversight. And they shouldn't be seen as a replacement for, good, secure coding practices and thorough code review by humans.
So we've covered a lot of ground today. It seems clear that application security is not a, one and done kind of thing. It's an ongoing process, constantly evolving.
Yeah, that's a crucial takeaway. The shift towards DevSecOps, integrating security right from the beginning of the software development lifecycle, along with things like, secure coding practices, using trusted libraries, standard architectures, learning from common vulnerabilities, taking advantage of automated testing. These are all critical steps toward building more resilient and secure software.
Yeah.
And as we've discussed, these new technologies like AI chatbots, they bring their own unique security considerations as well.
It really comes down to creating a security-aware culture, right?
Hmm.
Throughout that whole software development process, from the initial design all the way to, ongoing maintenance and updates, I think this understanding of application security is essential, regardless of whether you're actually building software or just someone who, relies on technology every day.
I completely agree. It's a complex landscape, but understanding these core principles empowers everyone to ask better questions and to really appreciate all the effort that goes into creating secure technology.
Thank you so much for joining us today. This has been a fascinating discussion.
My pleasure. It's been great talking with you.
And to all our listeners, thank you for tuning in. Be sure to check back for more deep dives into the world of software and technology. Until then, stay curious and stay secure.